Okay, ladies and gentlemen, this video is going to cover two additional examples like the one currently on the board, which was the first example from your Graphing Quadratic Functions notes. So here's the next example. Same setup. We're going to graph this function, state the domain in the range, identify the vertex, and determine whether that vertex represents a maximum or a minimum value. And we stated before, and we'll state again, that the actual graphing portion of this is not the big idea. It is an important skill. However, the big idea is understanding that all these other things about the equation, about the graph exist. The vertex, the domain and range, whether it's a maximum or a minimum, the y-intercept, the x-intercepts, things like that are very important that we be able to recognize them from the equation. So again, this is a several-step process. Step one is to identify a, b, and c. A is the number in front of x squared. In this case, that would be -1. B is 4, and C is 5. Now A and B are what we're going to use to find our axis of symmetry. C is the y-coordinate of your y-intercept. So the point 0, 5 is on this graph because C is 5. So we might as well mark it now because eventually we're going to be graphing it. 0, 5 is on this parabola. So our next step is to find the axis of symmetry. Once again, that equation is -b over 2a. X equals -b over 2a. That would be -4 over 2 times -1, or 4 over -4 over -2, which is 2. So our axis of symmetry is the line x equals 2. So if we graph that line, that is a vertical line through 2 on the x-axis. So here's our axis of symmetry, x equals 2, drawn in green. I'm drawing it in green because it's not technically part of the actual graph of your function. And as such, we don't want it to be in the same color as our graph if we can avoid it. If you do it in pencil, it's not a big deal. Okay? We're trying to graph our parabola. Our parabola is going to be symmetric around that point. Okay? Around that line. So we're going to create a table. That table needs 5 rows because we need at least 5 points to get an accurate picture of our parabola. Our middle number in the x column is our axis of symmetry. So x equals 2, our axis of symmetry, goes in the middle row. We pick 2 values below, that would be 1 and 0, and 2 values above, 3 and 4. Now again, once you get the conceptual idea here, your y-intercept will occasionally save you time. For instance, right now, your top row in your table says when x equals 0, f of x equals, well, that's the y-intercept. That would be 5. Now, if you're not getting that concept yet, it's not a big deal because we can plug in 0 to the equation, and when we plug it into our calculator, we get 5 anyway. So if you're not seeing it, it's not a big deal. Just plug the number into f of x. This equation up here on the upper right. See where I'm circling? Now, if the top row is 5, so is the bottom row. We move on to the next number, -1 squared plus 4 times 1 plus 5. That would be -1 plus 4, which would be 3, plus 5 would be 8. If this row is 8, so is the row below our axis of symmetry. So 3 also points to 8. Finally, we do the axis of symmetry itself, -2 squared plus 4 times 2 plus 5. That would be -4 plus 8, which is 4, plus 5 would be 9. We go over to the graph and we graph those points. Notice we already have 0, 5 because that is our y-intercept. 1, 8 is right 1, up 8. 2, 9 is on our axis of symmetry, right 2 and up 9. 3, 8, right 3, up 8. Notice the symmetry. Those are both 1 point away from your axis. And 4, 5. Okay? Now I want my graph to be as pretty as possible, so I'm aware, using some more math that you're not aware of, that this graph actually passes through a couple of other points as well. So I'm going to make sure that my graph gets to be as beautiful as it can. It also passes through -1, 0, 5, 0, 6, -7, and -2, -7. So anyway, we draw a nice smooth curve through the 5 points that we graphed. Okay, I'm also going through those additional points, but you don't need to worry about that yet. Okay, and there's the graph of our parabola. Now once again, notice that right up here at the top is our vertex, just like in the previous example. Our vertex is this point in the middle. Our vertex is the point 2, 9. The point that lies on the axis of symmetry is the vertex. And since this particular quadratic has a negative a value, it opens downward, which means that that vertex is a maximum value for this quadratic. On to domain and range. Remember that it doesn't matter what quadratic we're working for, the domain is always all real numbers. If it is a function and a quadratic, it is all real numbers. Every real number can be plugged in. Again, in interval notation, we're talking from -infinity to infinity. We can use every single number. For the range, it's a little bit different when the graph opens downward instead of upward, because now we're looking at f of x values that are less than or equal to our maximum value, our maximum y value of 9 for that graph. So when we write that in interval notation, we say, oh, well, our graph starts at -infinity, and as we move up, it goes all the way to +9. 9 is included in that range, so it gets a square bracket. If you're not fully understanding interval notation yet, that is not a big deal, because you're going to see it again all the time in Algebra 2 and Pre-Calculus. That completes that example. Let's do one more just to make sure we're all on the same page. So, our last example, again, first step is to identify A, B, and C. A is 2, B is 4, C is -3. A is 2, B is 4, C is -3. Now we've had 4 come up a lot for the B value. That doesn't always happen, okay, but it did this time. Anyway, again, the C value tells us that the point 0, -3 is going to be on our graph, so we might as well graph that y-intercept now. And the other two values tell us what we need to find the axis of symmetry. The axis of symmetry always has the equation -b over 2a, which means we change the sign on the b, it's +4, so it will become negative, and we plug 2 in for a. So 2 times 2, that would be -4 divided by 4, or -1. It is a complete coincidence that we got the same axis of symmetry as our first example. So we're going to graph that line, x equals -1, just for a reference point, as our axis of symmetry. So x equals -1 is your axis of symmetry for your graph. We are then going to create a table. Remember that that table needs to have 5 rows. One, 2, 3, 4, 5. And that the middle row should be your x value for your axis of symmetry. Okay, your axis of symmetry goes in the 3rd row. That means we're going to be using wrong direction there. We're going to be using -2 and -3 above that x value, and we're going to be using 0 and 1 down below. Now once again, we already know that 0 is related to -3, which means -2 will also be -3. Now if you don't see that, not a big deal. Okay, well, we can also get it by plugging it in. So when we plug -3 into f of x up here at the upper right, we have 2 times -3 squared plus 4 times -3 minus 3. That would be 18 minus 12, which is 6, minus 3, which is 3. Again, whatever this top value is also the value of the bottom row. The top row and the bottom row are always the same if you center on the axis of symmetry. For -2, if we plug that in, and again, we already know what this value is, but if we need to, we can plug in. Okay, we should get, in theory, -3. So this would be +8, -8, which is 0, -3 is -3. Whatever that value is, so is the row below the axis of symmetry, because we have our symmetry around that axis. Finally, we plug in -1. And we get 2 -4, which is -2, -3 is -5. Go to the graph and graph those 5 points. So -3, 3 is left 3, up 3. -2, -3 is left 2, down 3 from the origin. -1, -5 is on your axis of symmetry, left 1 and down 5. 0, -3 we already graphed. And 1, 3 is right 1 and up 3. So our graph, again, we need a nice smooth curve. And the reason we need those points graphed correctly is in case you don't have a nice smooth curve, we can still tell whether or not your graph is correct. So make sure those 5 points are graphed correctly, and then graph your parabola through those 5 points. Remember that the point that appears on the axis of symmetry is your vertex. That is, the vertex is the point located in the middle row. So for this parabola, the vertex is the point -1, -5. And again, since a is a positive number and this parabola opens upward, that vertex is a minimum value. It is the lowest point on the graph. And in fact, the range, the minimum value in the range is -5. So then we go to the list. The last part of the problem is to list the domain and range. The domain, again, for every quadratic equation, every quadratic function, is all real numbers. So we'd write that in interval notation as -∞ to +∞. And the range, we look at the graph and we move from the bottom to the top. The graph begins existing at the minimum value of -5. So in just as an inequality, we would say f of x is greater than or equal to -5. Now, again, in interval notation, which is not horribly important now, but will be, we would say the range starts at -5. And if you look at the graph, we go up to +∞. So in interval notation, we would say the range is from -5 to infinity. That does it for this video. Thank you for your time and attention.